Hey guys, we're back with lesson 11.2. 11.2 is our first delve into rationals. Rationals has the word ratio in it, and what that really means is a fraction. Okay, so everything we deal with for the next few lessons is going to be fractions, okay? But we're not going to freak out about them because really all it is a numerator, which is one polynomial, and a denominator, which is another polynomial. We know how to do things with polynomials such as factor, and then from there, all we're really going to do is cancel out or divide out factors that match each other. Okay, so we're doing things that we already know how to do. We're just adding one extra step in it, and we're writing it a little bit differently. So let's start over here with what is a rational expression. So that rational is ratio, fraction. Okay, so it means that we have a polynomial in the numerator and a polynomial in the denominator. Okay, so from there, let's talk about polynomial. A polynomial has numbers for coefficients. It can have letters or variables. And it can have exponents. But the exponents themselves have to be numbers. Okay, so the variables have to be like down below like an x, and then the exponent has to be a number. It can't be like 2 to the x power, which would be an exponential function, not a polynomial. All right, so let's review multiplying. When we multiply together our fractions, we multiply top times top and bottom times bottom. Okay. Coefficients are the big numbers that are in the front, and for the coefficients, you actually multiply them out. So whatever it says to do, like multiply, that's what you do with coefficients. And then you do something different with your exponents. You add together the exponents. Okay, for example, 2x squared times 5x to the 4th power. 2 times 5 is 10. And then for your x's, you add together the 2 and the 4, which is 6. When you divide your fractions, what do you do with your coefficients? So this is more like the simplifying. So when you're done with your multiplying or dividing or whatever, you end up doing something with your coefficients. Well, you do whatever it says to do with your coefficients. It says divide, so we are going to divide our coefficients. So that might mean actually dividing top divided by bottom, or it could mean simplifying your fraction. For example, 4 over 10, if you try and actually divide 4 divided by 10, it's going to give you a decimal. Now, if you do that in your calculator, you're going to hit the math enter, enter, right? 4 divided by 10, math enter, enter, and it will give you 2 over 5. Okay. However, if you do something like, let's go with 10 over 5, that will divide out nicely. It will give you 2, which is the same thing as 2 over 1, right? 2 and 2 over 1 are the same thing. So we just have to keep in mind what was bigger, the top or the bottom. Since the top was bigger, that's where the 2 goes. Okay, exponents. We don't do the same thing to exponents as we do to the coefficients. So if it says divide, we do something that is kind of like divide. It actually ends up being subtract. Okay. So for multiply, you multiply your coefficients and add your exponents. For divide, you divide your coefficients and subtract your exponents. Okay. We'll get some more practice with those here on examples 1, 2, and 3. So example number 1, there's no multiplication in this problem, okay, because there's no like times and then another fraction. So all we're going to do is the simplify or divide step. So how do we do that? We do 75 divided by 60. Simplify that fraction out. Now, 75 divided by 60 will give you a decimal, but if you hit math enter, enter, you're going to get 5 over 4. So this is the same thing as 5 over 4. That takes care of your coefficients, 75 and 60. Now the x's, you're going to subtract those exponents. Okay. But where we put our remaining stuff is going to depend on wherever the bigger exponent is. So notice that the x's, there's a bigger exponent on the bottom than on the top. So our remaining x's are going to be on the bottom of the fraction. Okay, so now let's subtract. Do big minus small. 3 minus 2 is 1, so that means that this is x to the first power down here. And of course we know that we don't have to actually keep that 1, that can be invisible, so 5 over 4x is the simplified version of what we started with. So for the x's, we looked where is the bigger exponent. That's where you actually write down the x and then subtract big minus small, and that's what you're left with. Okay. Example 2. This one says to multiply two separate fractions. So when we multiply, we're going to get one bigger fraction out of this. So multiply top times top. 12 times 6 is 72. And then add together the exponents for your x's that are on the top. X to the 4th times x is x to the 5th, because this has a little 1. Okay, denominator, 9x cubed times 15x to the 12th power. 9 times 15 is 135. X to the 3 plus 12 is 15. Okay, next thing we do. Every time you multiply, you still have to divide. You have to reduce those fractions. 72 and 135 are giant numbers. So into your calculator, type 72 divided by 135, and then hit math, enter, enter, and you get 8 over 15. Just keep the 8 on top and the 15 on the bottom. Now we look at x's. The bigger x exponent is on the bottom, so we put the x on the bottom, and then subtract those exponents. 15 minus 5 is 10, so just give it a 10. So you always subtract big minus small. Okay, number 3. Top times top, bottom times bottom. 2 times 60 is 120. X to the, add those exponents. 5 plus 10 is 15. On the bottom, 3 times 32, because those are the coefficients, multiply them together, is 96. X to the, add your exponents, 2 plus 4 is 6. And now that we're done multiplying, we divide or simplify. 120 divided by 96 reduces to 5 over 4. And then we look at our x's. The biggest exponent is on the top, so write the x on the top, and then subtract. 15 minus 6 is 9. So it's 15x to the 9th over 4. You will only end up with x's on the top or the bottom on these problems. That's it, not both. Okay, there will be a second video for the second half of this page.